Okay, you will open Rock Cycle in your Google Slides, and we are going to go ahead and get started. Essential questions are: what are the processes that are involved in the formation and classification of metamorphic, sedimentary, and igneous rocks? Number one, if you were quizzed today, what would you know the answers to already? What would you know about the rock cycle as of now? What parts would you need to learn more about to answer this question more confidently? In the rock cycle, what part of the rock cycle do you think you would need to know more about? Write your answer right here. Rock cycle, a model that describes the formation, breakdown, and reformation of a product. So right here, you'll see that this looks very much like, not like the circle of life, but it looks like a cycle. And so you start with magma and it becomes igneous rock, but the igneous rock can become metamorphic rock or sediments, and the sediments can automatically become sedimentary rock, but the sedimentary rock can turn into metamorphic rock or sediments. And then the metamorphic rock, of course, can become sediments or magma. So, what do you notice about this image to the right here? What do you notice? Give me an example of what you see here. Is it fluid? Does it go from one step to another, or does it go to many different places? Right here, use the rock cycle pattern to describe how material that makes up the sedimentary rock can become an igneous rock. Rearrange the steps in the correct order. So, because I am presenting, I cannot drag this down, but we're going to call this 1, 2, 3, 4. Okay? And we're going to match this up here, here, and here. So, what is first? Metamorphic rock gets pulled underneath the crust and melts into magma. Lava forms igneous rock. Sedimentary rock undergoes heat and pressure to become metamorphic rock. Our magma moves toward the surface and becomes lava. 1, 2, 3, or 4 goes in step number 1. Okay, for step number 2, what happens after number 1? Is that metamorphic rock gets pulled under the crust and melts into magma. Lava forms an igneous rock. Sedimentary rock undergoes heat and pressure to become metamorphic rock. Our magma moves toward the surface and becomes lava. Is it going to be 2? Which one is it going to be? 1, 2, 3, or 4 for the second step? You will grab it and you will pull it down and put it there. Now for step 3, which one is it going to be? 1, 2, 3, or 4? Metamorphic rock gets pulled under the crust and melts into magma. Lava forms igneous rock. Sedimentary rock undergoes heat and pressure to become metamorphic rock. Our magma moves toward the surface and becomes lava. 1, 2, 3, 4. Which one of those steps becomes step 3? And of course, by now you have step 1, step 2, step 3. So whichever one is left over naturally is going to be step 4. Sedimentary rock is formed when sediments accumulate and compact and cement together. They're often deposited in layers and contain sand, pebbles, and frequently fossils. Examples are sandstone and limestone. Something that you'll see a lot of is little canyons, such as the Great Canyon. The Grand Canyon in Arizona is made out of sedimentary rock. Physical properties of sedimentary rock. You have sand, you have pebbles, and even boulder-sized particles. Some may even contain fossils. For example, you see here, there are fossils in here. Okay, how is sedimentary rock formed? I want you to take and give me a sentence and make sure that you pay attention to this previous slide and these information to answer this question. Try to come up with 3 ways by which rocks can be broken down into smaller pieces known as sediment. So landslides. How can rock be broken down into sediment? With landslides, you're going to put your answer right here for landslides. Okay, freezing and thawing. With the ground freezing and thawing, how does that make the rocks break down into smaller pieces and turn into sediment? You will write your answer for that right here. How can rocks be broken down into sediment? That is where you will put this answer right here. By what process are sedimentary rocks broken down? You have weathering. By weather, you mean rain, ice, wind, chemical changes in living things, such as plants, dogs, animals, things like that. It creates loose material, and this loose material is called sediments. How are sediments moved? Deposition. They are deposited in layers. They're eroded over time. They are worn by wind and water and gravity and ice. So right here with these pictures, what you're going to do is you're going to determine which one is gravity, which one is wind, and which one is water. Compaction. Sediments are deeply buried, placing them under pressure because of the weight of the overlaying layers. Cementation is when new minerals stick to the sediment together, just like cement. This holds the grains together very tightly. Okay, so what you're going to do is you're going to drag these two to their right place. As sediments build up, the weight of the sediment blank all the loose rocks together. New minerals also come along and blank the loose rocks together.
Students, please excuse this interruption.
So you're going to take, and I know you probably cannot see this part right here, so you're going to put number 1, number 2, and then you're going to take and tell me which one is number 1 and which one is number 2. Quick action. Add these sedimentary processes to the diagram. You have weather and erosion, W plus E, compaction, and cementation. Okay, so you need to determine, you have 1, 2, 3, 4, 1, 2, 3, 4 choices. You're going to take and drag and click it to the appropriate place. So starting with igneous rock to sediments. Is that weathering, erosion, or compaction and cementation? Sediments to sedimentary rock. Is that weather erosion or compaction and cementation? And vice versa, sedimentary rock to sediments. Is that weather erosion or compaction and cementation? Metamorphic rock. Is that going to sediment rock? Is that going to be weather erosion or compaction and cementation? Think about the rock cycle and the properties of sedimentary rocks. Use your knowledge to explain how sedimentary rocks may provide data for scientists to analyze. What data might be found? How could the information be used? Okay, sedimentary rocks sometimes contain what? What do they contain? Based off of what we've learned here on these 2 slides, what do they contain? And how can they use them? Use that information. You will type your answer right here. Metamorphic rock is formed by heat and pressure while buried deep below the Earth's surface. It has layered or banded ribbon-like appearance or may have crystals. Examples of metamorphic rock is gneiss, marble, and slate. Physical properties of metamorphic rock. Layers look like ribbons. It has crystals. It has layers of ribbon, layers that look like ribbons, crystals. How are the layers of metamorphic rock different from sedimentary rock? So, how are they formed differently? What makes metamorphic different from sedimentary? Type your answer right here. What are the processes that form metamorphic rock? You have heat. It's caused by magma. Temperatures high enough to change its structure, meaning its composition, how it's made, but not to melt it. Heat can change sedimentary, igneous, or other older metamorphic rocks. What are the processes that form metamorphic rock? Pressure is caused by intense collisions and friction of the tectonic plates and pressure from overlying rock layers. Deep underneath the Earth's surface, and pressure can change sedimentary, igneous, or other older metamorphic rock. Igneous rock is formed when lava or magma is hardened. It is found near volcanoes and fissures, meaning cracks in the crust. Examples of this is basalt, obsidian, and granite. Physical properties of igneous rock. It's fast cooling, slow cooling, it's glassy-like, it has large crystals, it has holes where gases were trapped, and it can be many colors. How does the appearance of igneous rock differ from sedimentary and metamorphic? So these are all igneous type rocks, and here are our metamorphic rock right here. Okay, and then we have our sedimentary rocks. What do you see that makes it so different from the sedimentary rocks and the metamorphic rocks? What makes it look so different? Write your answer right there. What are the processes that form igneous rock? They melt. They is caused by the increase of temperature in the rock deep below the Earth's surface. Is caused by friction between crustal plates. You have lava, which is molten rock material on the Earth's surface, and then magma, which is molten rock underneath the Earth's surface. What is the difference between lava and magma? Look at these and tell me what the differences are between the two. The rock cycle. Slow cooling happens below the Earth's surface as magma cools, forming large crystals. An example of that is granite rock. Fast cooling happens on the Earth's surface as lava cools, forming small crystals. Examples of this is obsidian, basalt, and pumice. Some of you guys may have seen your mom or your dad go get their feet done or use a pumice stone to take and scratch and scrape away dead skin on their feet. That is what pumice stone is. What are the processes that form igneous rock? Cooling and hardening. Melted rocks that turn solid. All right. So let's talk about our quick action real quick. We're going to add the metamorphic and igneous rock processes into the diagram. We have heat and pressure, which is H plus P. We have melting, which is M. And then we have cooling and hardening, C plus H. So let's start with sedimentary rock to metamorphic rock. What happens? H plus P, M, or C plus H? Now let's go with metamorphic rock to magma. What happens? H plus P, M, or C plus H? You'll drag and click it over. Magma to igneous rock. What happens? H plus P, M, or C plus H? Now, igneous rock, back over to metamorphic rock. What happens? H plus P, M, or C plus H. Drag and click it there. What data might be used in analyzing rock samples to determine the rock type? What could it tell you when the rock was formed? So, the data is numbers, something that can be measured. Crystals, blank, and blank of holes are two things that could be measured to help determine the type of rock it is and how it is formed. Crystals could be measured and holes could be counted. And this would tell you if it is a blank rock formed quickly or slowly above Earth's surface or below. So you're going to refer back to your vocabulary words up here, and you're going to determine where these go, the different type of rocks here, where they go, okay? Quick action. Complete the table by clicking on and dragging the property cards to their correct position. So you're going to look at these and you're going to place your description under sedimentary, under igneous, or under metamorphic, okay? So you're going to put your examples here, your description of what it looks like here, and then how it is formed here. Last look. Click and drag on each card to its correct location. If you need to rotate a box, click on the box and use the arrow here to spin it. Okay? So what you're going to do here is you're going to decide what kind of rock is made. Okay? And you're going to put your term here and you're going to tell me what's happening in the picture. Okay? So your process here is going to tell me if it's heat or pressure or if it's cementation. That is your process, your blue processes. Okay? Now your tan processes, you're going to tell me if it is compactation, heat and pressure, or cooling and hardening. And then your terms is where you identify what kind of rock it is to start with. Okay? Now we're going to check for understanding. We're going to identify the processes involved in the formation and classification of igneous and sedimentary and metamorphic rocks by rearranging the colored boxes to the correct place in the chart. So, igneous. You need to match what an igneous rock is and how it was formed to the right place and move one of these out of the way and put the right answer here. It is not the right answer this way right now. Which of the essential questions do you still need help with? You're going to take and you're going to type your question here. If you do not understand anything that we have reviewed just yet. Okay? For sedimentary, you're going to do the same thing. You're going to drag and match the process that sedimentary rocks are found and put it here. Same for metamorphic. If you have any questions, log into our Google Meets on a daily basis or give me a text or a call and ask your question.